Hello and welcome to Mrinal's Math tutorial. Today we are going to look at the paper 9709 11 May June 2020. Let's begin. In question number 2, we have the coefficient of 1 over x in the expansion of kx plus 1 over x to the power of 5 plus 1 minus 2 over x to the power of 8 is equal to 74. We are required to find the value of positive constant k. So, if you remember, the general term in a binomial expansion is given as NCR a to the power of n minus r b to the power of r. If you're struggling to remember this, please go into the playlist and look for binomial expansion playlist and watch the video on finding coefficient of general term in the playlist. Yeah. So here we need to find the coefficient of 1 over x for the first expansion and also for the second expansion. These two coefficients added together is equal to 74. So we're going to find the coefficient of 1 over x in kx plus 1 over x to the power of 5. So here the value of n is equal to 5. So 5r, r we need to work it out, kx to the power of 5 minus r, 1 over x to the power of r. So let us set up an equation with x and its powers, and x to the power of 5 minus r, x to the power of 5 minus r times, here the x is in the denominator with power 1, so if you take it in the numerator, it's going to be x to the power of minus 1, everything to the power of r equal to x to the power of minus 1. It is equal to x to the power of minus 1 because we are looking for coefficient of 1 over x. So the power of x in the denominator is 1. You take it in the numerator, it becomes x to the power of negative 1. Use the rules of indices to solve this. So x to the power of 5 minus r, because these two multiply, is equal to x to the power of minus 1. So x to the power of 5 minus 2r is equal to x to the power of minus 1, or we could say that since the bases are same, we equate the exponents. So 5 minus 2r is equal to minus 1, or 6 is 2r. That gives me r is equal to 3. Now, go ahead and replace this value of r in this equation over here in the general term. So we're going to replace r as 3 in all these places. So we get 5c3 kx to the power of 5 minus 3, which is 2, 1 over x to the power of 3, and 5c3 is equal to 10 k square x square times 1 over x cube, which simplifies to 10 k square times 1 over x. So this is your coefficient of 1 over x in the first expansion. Now let's go ahead and try to calculate what is the coefficient of 1 over x in the second expansion. This is going to be easy because here we are having only one x, so it's going to be much easier to calculate the coefficient of 1 over x. So again we set up in general term. So we have the power is 8, 1 minus 2 over x to the power of 8, 1 minus 2 over x to the power of 8. So the general term would be 8cr, 1 to the power of 8 minus r minus 2 over x to the power of r. We want the coefficient of 1 over x. So obviously the power of r should be 1. So replace r as 1 everywhere. So what do you get? You get If you replace r as 1, you get 8c1, which is 8c1, which is equal to 8. 1 to the power of anything is 1, times minus 2 over x, which is minus 16 times 1 over x. That means the coefficient of 1 over x is minus 16. Now these two coefficients, when added together, is equal to 74. So what we are going to do is, we are going to add 10k square minus 16 is equal to 74. Collect the like terms. So 10k square is equal to 74 plus 16, which is 90. Or k square is 90 divided by 10, which is 9. So k is positive square root of 9, or k is equal to 3. We have taken only the positive square root of 9 because the question mentions that k is a positive constant. So that's about it. So you have got k equal to 3, and that's the solution for question number 2. If you haven't subscribed to my channel, please go ahead and hit the like button and share and subscribe. Thank you for watching.